Hey, folks.
Hello.
I love.
Will, I thought of you when I was in Nashville. I went to a bar and they had something called the Recession Special, and it was $6 for a fried bologna sandwich, a bag of chips, a moon pie, and a can of PBR. And I got it, and it wasn't great.
What, the PBR wasn't great? I don't believe that.
No, the PBR was the best part. The bologna sandwich was a little questionable.
Still, it's funny you say that. I was at the grocery store the other day, and I had just finished watching Stranger Things, and I was craving like a bologna sandwich. I was like, man, that was like my poverty meal when I was a kid. So I got like the like boar's head, so I got a little fancier bologna, like cut
Yeah, I
really
think
thick, and
fancy's the
then
way to go.
I made like I put it on the griddle, and I made like a fried like a fancy version of the bologna sandwich, and grilled the bread and everything. It was amazing. Worth every all 1,000 calories, I'm sure. It would have been better with the PBR, but whatever. I didn't
Well,
have
I
it.
heard you say this before, and I don't know what you're talking about because bologna would have been luxury for us.
I
Like
mean, that was as good
it
as
was
it got when I was a
meat.
kid. That's all my parents could afford to feed two kids was bologna sandwiches.
No, I'm saying we didn't get bologna because it was too expensive.
No.
That's pretty good.
Hey, Misa's back. Where are you guys? Is that like a post house coffee or
It's
lunch?
uh it's the Schoolyard Beer Garden in Denver. It was near the house.
Oh, are you there too, Will? Did you guys all go to a house? This
Yep.
is house
It was
party, the new
actually right.
meaning of house party.
Yeah, it was right down the road from the office. So um I I stayed here last night, so I just went over and helped with the setup.
Cool. Well, hey, I threw out a crazy question. I don't want to take too much time with this. Obviously, it's something that we could take the whole hour. So we'll go really fa Sorry, not Paul. Paul, you are going to take the whole hour. But my intro question, in case you didn't get it, was one or two things that you regret in your life, and you can only say two things if they're really short. Um, let's see. Marilee, since you have to leave, we'll start with you. I'll put order in the chat. Um, so Marilee, you can start while I'm putting this
Okay.
order in the chat.
Um,
Oh, wait, I will turn off the recording. Ha! Where,
darn. No,
where,
I'm
wait,
kidding.
wait, wait, where is it? Where is it? Where's the, okay, okay, there's this.
Uh,
I'm
yeah,
really
so,
sorry. I really wanted to record this one, but then I messed up.
oh well. Um, yeah, so where we have high polluting locations, we want to have ventilation in those on demand and then something for just general ventilation overall. So that's how it's tended to be looked at. One of the things that's been interesting is, of course, not every house um, has the same contaminants, right? I mean, obviously that's true, and yet that's part of why this is a minimum worst you can do. But one of the things that I think people have been starting to try to do is be a little more thoughtful about specific contaminants to focus on and perhaps, targeting those. So while I don't like how it was done, many years ago, a thing got put in that said you can reduce your ventilation rate if you have good filtration on the grounds that particles are one of the most important things to get rid of in homes. There are some studies that suggest that particles are, on average, the single most hazardous contaminant in residential buildings. So if you can deal with those, then you can reduce your overall ventilation rate. Like I say, I don't like how it was done, but it was done. So that was the first time we really targeted a specific contaminant in how we dealt with ventilation.
Do you believe that? Sorry, just breaking in. Do you believe that you can reduce ventilation rate if your particles are okay?
That's what I didn't like. I was absolutely fine with doing things to reduce your particle levels. What I didn't like was allowing every other contaminant to be higher in exchange. So no, I don't believe that. Um, and I honestly could have killed it, but I was chair at the time that that went through, and it was not my job to kill things. So no, I don't believe it. I've never liked how it was done, but it is there. And the one thing I do like about it is that there's at least some people starting to think about focusing on specific contaminants, which gets a little bit on the road toward best practice instead of worst you can do. More recently, something that I really do like is I just told you, 50 CFM in bathrooms, 100 CFM in kitchens, all these things. That's all prescriptive. More recently, like in the last couple of years, we approved what's called the IAQ procedure. There had been an IAQ procedure in ASHRAE 62.1, which is non-residential buildings, for a long time. That's more performance-based. So it's basically, it focuses on particles, nitrogen dioxide, and carbon dioxide. And if you have a ventilation system that can keep those contaminants below a certain level, then that is deemed to be good enough. And if that means you have to put in more than the minimum prescriptive, fine. If it means you can put in less, but you're actually achieving good results, fine. One of the things I do like about that is that there was a really quite a bit of analysis done to try to identify, right, there's still a requirement to have the local exhaust in bathrooms and kitchens, but beyond that, there is no spec for flow. It is what flow have you determined is going to be needed given what's in the home to keep those contaminant levels low. It provides a pathway for things like indoor air quality monitors to drive what potentially a variable ventilation rate. So it's a path to be more innovative, I think, to do things that really achieve the goal, which is good indoor air quality, instead of just throwing something at it and hoping for the best. Um, and one of the things I do like about how that was done, like I was starting to say, was that a lot of analysis was done. What are the most important contaminants? And while, of course, that leaves a whole lot of contaminants out, then there was some thought of, well, if we do a good job of getting rid of those, given the nature of where those come from, do we think we're going to be doing a decent job of getting rid of a lot of others? And the answer is yes. If you use those as kind of key contaminant proxies, you're getting more than those. If you can ventilate so that if it was just CO2, yep. Good luck, Marilee, with whatever you got to do. Yeah, where was I going? Yeah, if you're just doing a single contaminant like CO2, well, CO2 mainly comes from us breathing. It doesn't come from us cleaning. It doesn't come from us cooking unless it's gas cooking. So all kinds of contaminants can go up and down in ways that CO2 does not track. So if it was just one contaminant that was in the IAQ procedure, I would not at all have supported it. But the fact that they looked at things that were related to activities, things that were related to people, things that were related to different sources, I think makes it a really solid thing to do. So yes, I was very pleased to see that one go through. And I wasn't a main driver of it, but as one of the people on the committee who does know something about indoor air quality, the people who were really focused on developing it, they always ran it by me to see what my thoughts were, see if they had my support on it. And then, when we got to a really critical mass of people, we were able to get that through. And I think I don't think it's going to be a lot of houses that follow that right now, but it's a pathway to do better, even within a minimum standard. And that's one of the things people are looking for is options to be able to do better. So one other thing I definitely wanted to share with you that I think is maybe most relevant to sapphires is, for 18 years or so in the residential ventilation standards, all it really was this minimum worst you can do. Well, then in 2020, this really bad thing happened called the pandemic, the COVID-19 pandemic, made people think about ventilation differently, right? Because the normal ventilation rates that we have in these standards is not enough to deal with that. Parallel that to sapphires. The normal ventilation rates we have are not enough to deal with bad outdoor air. They're not even designed to deal with bad outdoor air. So, in fact, there's kind of almost a religion around outdoor air being the goal. What we're trying to do is bring in outdoor air. And if it's not outdoor air, it's not good. But we know that a lot of times outdoor air is not good. But so what happened with the pandemic was a whole different standard got written of here's what you should do for infection control. Much higher ventilation rates for ventilation control. And then we brought in to the ASHRAE residential ventilation standard 62.2, what's called an informative appendix. A normative appendix is you have to do this. Informative appendix is you don't have to do this to meet the minimum requirements of the standard, but it may be helpful. So we put into place, and I was involved with getting this in, we put into place an informative appendix that was basically, if you want to set your house up to have sufficient ventilation for infectious disease transmission control, here's the things you would need to have in the home. And it's not that they have to run all the time. They have to be available for when there is some kind of infectious disease issue. And it doesn't have to be a pandemic. It could be somebody's got the flu in the house, right? And there are people who wanted to make that normative, meaning you have to do that in every house, but it would have been ridiculous. It would never have been adopted by retrofit programs. But it made it so that if people wanted to do better and wanted to account for infectious disease control, they had a recognized, ANSI accredited, consensus-based standard that says this is what you should do if you're trying to get there. So people aren't just making it up. I feel like that's something that, depending on how our project goes and how it got adopted by others, if there are contractors or not contractors, manufacturers who wanted to pick up on the technology and develop it and try to get something out there, I could see an informative appendix being brought into the standard that says, if you want to deal with polluted outdoor air, here's what you need. And our work informs that. And now with that one on the infectious disease control, we have, I think, a very clear template for how that works, which I find kind of exciting and an opportunity to get beyond worst you can do and closer to best practice, or at least accounting for non-standard conditions. And again, to kind of reiterate, something that Tammy asked me to talk about earlier on, this would be mainly implemented by your local HVAC contractor kind of person. It's not design engineers so much. It's not, one of the things about residential buildings is most of them don't have an engineer involved. You're dealing with contractors. And so that's who this has to be usable by. So I'm going to pull up there and see what conversation people feel like having, if any.
Hey, Paul, this is Tammy. I can't raise my hand anymore, or I don't know how. Um, so I guess one thing that is kind of buried here is that, or in a possibility of responding to events or responding to pollutants, is that ventilation was never prescribed as something that could adapt. We probably have the sensing technology now to be able to do that, and probably some commercial spaces are doing that, but we're not really doing that in residences. Is that correct? That it isn't and hasn't been designed to rely on an adaptive response?
That is absolutely correct. The kind of first even semi-serious entry into that was this IAQ procedure, where if you have a system that is designed to keep that set of contaminants low, so which then could include things like ventilation that automatically comes on whenever you're cooking, ventilation that comes on based on a CO2 control, things like that. But before that, yeah, there really wasn't any kind of adaptive what's going on right now.
Do you think that I was going to ask a question, but maybe I should, and I don't want to take up the space. I can't see who's interested anymore, so you're going to have to self-select. But I will ask this question and let other people ask. Can you know enough about 62.1 to draw parallels between residential and commercial? Like what can residential do, or what must they do that commercial doesn't have to do, and vice versa, just because of the very different um, methods of operation and installation?
Sure. So, yeah, when you look at 62.1, there's actually a whole lot of similarity. It's still rates that are mainly based on some combination of number of people and square footage. Some of them are based on only square footage, some of them are based on only number of people, and some of them are based on a combination. So, in that sense, they are very similar. Um, there are there are a few other requirements because in commercial buildings, you tend to have sort of like with multifamily, multiple occupancies next to each other. There's quite a bit about transfer error, both in terms of that compartmentalization, like you would do in multifamily, but also you have a lot of shared ventilation systems. And so, how do you make sure to not have those systems have some kind of bypass where air from one occupancy gets to air in another occupancy, especially when you got a restaurant over there and you've got a retail over there and they have very different use cases and you want and so they've got one of the things 62.1 does is they rate different spaces by class of air. Like, is this air going to be relatively clean air? Is this going to be really horrible air? Or somewhere in between, and that will drive some of the decisions of what kind of ventilation systems you can have. Um, and then, another thing, they tend to not have so much of these local exhaust requirements because they don't have the same they don't have the same usage, activity patterns as we do in residential. If you're not a restaurant, there's not cooking for the most part. Um, and commercial kitchens have to have huge ventilation. Um, so it tends to be actually much more supply ventilation, actually a little more parallel to what we're doing if we do the furnace integration method in sapphires, that's going to be a little more akin in some ways to what's done in commercial buildings than in residential. Anybody else? Tammy, you were not taking over from anybody else. Nobody else has their hand raised.
Yeah, well, I have a lot of questions, but I don't want to crowd people out.
Yeah, so I have
Um,
I have I have one.
yeah, go for it.
So I know you talked about who the users of the standard are. From the ones I've been involved in, there's often a difference between who the users are and who are the ones actually pushing for those to be put in place. Those aren't always the same folks.
Yep.
In this case, do you feel like those who are having to use it and those who are pushing to say that it is needed are the same people, or is there a disconnect there?
No,
Or
huge disconnect. That's one of the huge challenges in weatherization. So weatherization first adopted requiring 62.2 back around 2013. And even among the practitioners, the people working in weatherization, um, I mean, they were throwing they didn't bother with something as squishy as tomatoes to throw. They were throwing rocks at the people saying you got to do ventilation. Nowadays, they're much more on board. They've gotten to understanding it, but so many residents don't understand why you're cutting a hole in their ceiling and putting in something that takes heated air and throws it outside. They thought you were replacing their windows, and they don't like it. They don't understand it. They don't want it. And one of the first things they want to do once you leave is to disconnect it. So yeah, the people pushing it think it's important, and the people using it don't understand it. And so I think one of the biggest challenges we've had, and there have been success stories and there have been failures. Um, but one of the big challenges has been coming up with educational materials that are sufficiently convincing and compelling and understandable by the general public to explain why this is actually a really good idea and really important, and it doesn't truly cost a lot of money to operate. See.
Yeah, I can say my question out loud.
Okay.
It might take us in a slightly different direction. So if somebody was trying to build on Christian's comment, we don't have to go this way. But I'm wondering, as you were talking, I think you alluded to like room for improvement, like the standard could improve, in ways that you expressed and maybe just sort of implied. But I guess I would love to hear your thoughts on like how much benefit would we get by improving the standard versus enforcing the one we have? And does that feel like a false like comparison, or does it feel like a useful one? Maybe in reverse order. If not useful, then move on to somebody else's question.
Yeah.
Does that make
No,
sense?
yeah. No, I mean, I think enforcing the standard could be huge just because so many people don't have ventilation at all. And
Uh-huh.
and so going from nothing to something could be a huge impact, but it's still worst you can do minimum. And a lot of times it's just not really addressing the issue. And so I think there's a lot we could do within the standard to truly improve health. And I think as um, monitoring has improved, sensors have improved, as technology has improved in, controls and monitoring not just one place, but a number of places. I think we have a tremendous opportunity over time to go from worst you can do, where we're trying to avoid having disasters, to
Uh-huh.
truly driving homes that support people's well-being.
Yeah. Thanks.
Well, following on Ellis's question, she asked about enforcing the existing standard versus improving one. Uh, how well is it enforced? It sounds like if you're doing it at weatherization, a house that gets touched by weatherization has to check it, but then there's a whole bunch of houses, like most of them, that are not getting weatherized. And so how can you tell, or how does anyone tell if a home has been built with proper ventilation and then if something has gone wrong, and it no longer has proper ventilation, but how does one know, and how does one go about fixing it?
Yeah, and certainly for older buildings, the primary entry point is going to be programs. It's not something people are just going to choose to do on their own. Um, Newer construction, a lot of so like codes have adopted a lot of the ventilation rates that are in 62.2. They just haven't adopted the entirety with all of the other requirements. So for newer homes, you will often see the standard being implemented, and then enforcement is really about somebody on the backside, what quality control inspector, building inspector, whoever, commissioning person coming and making sure, measuring the flows and making sure that it's actually operating. One of the things, though, that we have done, we have had to wrestle with in the committee is recognizing that the fact that we on the committee know a lot about this stuff doesn't mean most people do. And we have to recognize that if we think this is important, and we shouldn't be bothering with it if it's not important, if we think it's important, we have to do some things to try to get it to be used and implemented in a way that actually has an impact. And so, like when the standard first started getting adopted, it said you had to have a readily accessible override. Well, people were putting it on regular wall switches, and the first thing the user would do was go switch it off. And now we've just spent, $1,000 putting in something that's doing absolutely nothing. So on the committee, we had to think about that. And one of the things we did was say that an override, readily accessible override, can be the circuit breaker that it's on. And then if the circuit breaker also runs other things, people don't want to turn it off. It lets them turn it off when they're cleaning the fan. But if it's also going to shut off some of their lights or their television or something like that, it's going to make it harder, not impossible, but harder to override. So we have had to put in some kind of user-proof functionality to improve the possibility of it being enforced by those who are installing it.
Yeah, because I think through this whole thing, I haven't. I understand that you have standards, that there are standards. It just seems like it would be really easy to have a house without standards, and that, or that doesn't meet standards, and that is emphasized by the fact that I have no idea what my whole house ventilation rate is, or how I would tell. And I know we have this thing, right? Like, I'm supposed to know a lot about this, and I think I would guess that even people who are interested in ventilation don't know how to do this, or what the standard is, or how to check.
Yep. That's true. And then another thing about it, it's always changing. So you might have complied with it in 2010, but it's all different now.
So you're not making a case for for information, or you're not making a case for the state of the information that's out there, right? I'm not. Yeah, it doesn't feel accessible, I think.
Yeah, that is. I mean, and that's why, for the most part, is really only through programs where people are required to get training on this, and they've got like online tools where they enter their data collection information, and it spits out, this is the flow rate you're going to need. So it's really only those people who truly, I think, are able to access it in a broad level. Fortunately, I think most large utility programs use it. The weatherization program uses it. So there are a lot of places that are using it with trained professionals to figure it out. But they also do need to have that kind of educational material for the residents so that residents aren't up there with wire cutters making it so it doesn't run anymore.
Yeah, but like as compared to vehicle emission standard, I would say it sounds like the coverage is not anywhere near,
That's right.
right? Because with the emission standard, you have in some places annual or biannual inspections. It can't go out the door unless it's approved, and then the vehicles turn over a lot quicker. So eventually,
Yep.
most of the vehicles on the road are going to be standardized, which is not true in homes.
Right. Yep. And we're a couple minutes over time. I didn't know if we'd fill the whole time or not, but here we are a little past 1:50. Are there any other questions?
Well, thanks for doing this. I could ask more questions just about the whole system of getting people to breathe good air, but yeah, it's probably a whole broader discussion about. Yeah, I could definitely go down some roads about what does this mean for the sort of market system of clean air and clean air products. Yeah.
Mhm.
Yeah, I don't know that my question will be quickly answered, but I think my bottom line question is, um, if all slumlord rental property owners were to at least implement the current standard, do you think things would be better for the people living in those spaces?
Absolutely.
Okay, yeah, thanks.
Very quickly answered, yes.
Yeah, I know that definitely could be more, but that's kind of where I was coming from with the earlier question, but just more
Yeah.
broadly.
Yeah, and having been in a lot of really rough housing, yeah, you get even a little bit of regular decent ventilation in.
Yeah.
And there are kind of some of those testimonials where people be like, wow, ever since you've made these improvements to my home and we've got this ventilation, it's like I don't have to reach for my inhaler anymore. Or
Uh-huh.
it's 10% of what I used to do.
Yeah.
So we know that there are cases where it has absolutely totally transformed people's lives.
Thanks. Really appreciate you sharing.
Absolutely.
Yeah, thank you for doing this.
Yeah. Happy to. And I guess we're a few minutes over, so wrap up.
And thank you, everyone. Have a good weekend.
Yeah. Have a good weekend.
Thanks. Bye.
Bye, everyone.